everybody, and welcome to the first video on the parabola. In this video, we will be looking at the equation of the parabola and how to identify that being an equation for a parabola. So one of the things that will be common in all three forms that we look at is that the degree of the polynomial is 2. What does that mean in normal English is that there will always be an x squared term somewhere. So we will go through these different forms of the parabola, which they can be written in, and go through the different aspects of each of them. So the first one is called standard form, and in standard form we have the equation y is equal to ax squared plus bx plus c. There are three parameters in this equation, a being the coefficient of x squared, b being the coefficient of x, and c being our constant term. This form should look very, very familiar as this pops up whenever you're working with a quadratic expression. So you've seen it in quadratic expressions, quadratic equations, and maybe even in sequences in series when you're looking at a quadratic pattern. So this is your typical quadratic standard form. Now from this form in our equation, from our parabola, what we can get is the y-intercept. So C is always where does your parabola cut the y-axis. The second form that we got here is turning point form, and from the name we get the turning point. So we have the equation being y is equal to ax minus p squared plus q. Again, there are three parameters. So a we'll call the shape parameter, p is the x coordinate of the turning point, and q is the y coordinate of the turning point. So from this equation, we can get the turning point that can be written as P star and Q. Now, why I have written it as P star is that from the equation to the actual point, you have to change the sign to get the turning point. So that is the turning point. The next form is called root form, and the equation is y is equal to ax minus x1 times x minus x2. And again, there are three parameters. So A again is the shape. X1 and X2 are your x-intercepts or roots. And again, I've written it as x star and x1 star and x2 star because you have to remember to change the sign to get the actual coordinates. So you can see there's a pattern then where the stars are. If in the original equation there's a minus, then it should be a star. So those are the three different forms of a parabola's equation, and you could easily move between forms by using the algebra techniques that you have learned. So for example, to get from form A to from the standard form to the turning point form, then you'd have to complete a square. To get from standard form to root form, you would have to factorize. And to go from either root form to turning point or turning point form to standard form, you just multiply out. So the algebra that you have been learning is very, very important for having the ability and skill set to work with functions. So please make sure that your algebra is on track. The next thing I would like to point out is you see that all of them have this A value. So the A gives us the shape of the parabola, and there's two cases. So A can either be positive, and in which case this is the shape of the graph. Can you see it's a positive? It's a happy smiling face. And this shape of the graph always has what we call a minimum value. So this here has a minimum value. When A is negative, then what we have is this downwards facing parabola, and this graph would always have a maximum. So A would dictate which of the two classes that we are dealing with. And please pay attention to that because it helps us simplify our questions. So here are a few questions, and it's a really easy exercise for this one. It's what form? So we just need to identify the form. And we will go one step further. We'll say, what shape does it have? Is it a positive shape or is it a negative shape? And if there's anything special about the graph. So the first one, we have that it is in standard form. Okay, it's in the form ax squared plus bx plus c. So it is in standard form. What shape does it have? We're looking at the A, which is the coefficient of x squared. It's positive, so it's an upwards parabola. You don't have to draw the eyes to the smiling face. So it's an upwards parabola. And what else can we tell about the graph? Well, in standard form, we know that the y-intercept would be 0 and 4. So all of that information we could get just by looking at the equation of the graph. Let's have a look at the next one. So what form is this one in? So it's in the factorized form, so it is in root form, okay? And what shape does it have? So we have to look at the value for a for the shape, and a is -1, so it is downwards. And what can we tell about this form is we can immediately say what are our x-intercepts. So the one is 1 and 0, and the other one is -4 and 0. Can you see I've changed the sign from the equation, which you need to remember what you to do that if it is in root form. Let's have a look at the next one. So this one, again, if we look at the equation, it's ax squared plus bx plus c, so it is in standard form. What is the shape? Is it a positive one or is it a downwards one? So we look at the value of a and it's a positive one, so it's an upwards graph. And what can we tell from standard form? We can tell what the y-intercept is. And again, the y-intercept is 0 and -5. For the last one, we have a look at the equation. It's in the form a times x minus p squared plus q, so it is in turning point form. And what shape does it have? So we look at the coefficient, we look at a, and a is positive, so again it's an upwards graph. And then what can we tell from this graph? We can tell what the turning point is. So the turning point, the x coordinate comes from this term over here. We have to remember to change the sign. So this is negative, so it will be +3. And our y coordinate is 1. So that was a quick exercise. And you can see how much information you can get from the equation just by looking at it and knowing the different forms and what they tell you. Please have a look at our next video for more information on the parabola.